Today my topic name is Newton's ring. Introduction to Newton's rings. Newton's rings are a series of concentric circular interference patterns observed between a convex lens and a flat glass surface. These rings are formed due to the interference of light waves reflected from the top and bottom surface of a thin air film. The phenomenon is named after Sir Newton, who first studied and explained this optical view. Historical background. Newton observed this interference pattern in the 17th century while studying light and optics. The first systematic explanation of Newton's ring was provided by Newton himself in his work on light and color. The study of this ring has contributed significantly to understanding the wave nature of light. Formatting of Newton's ring. When a plano convex lens is placed on a flat glass surface, a thin air film is created between them. Light reflected from the top and bottom surfaces of this air film interfere, producing a pattern of bright and dark ring. This radius of the rings depends on the thickness of the air film at different points. Condition for formation. Monochromatic light is typically used to observe clear and distinct Newton's ring. The surfaces involved must be smooth and clean to produce well-defined interference patterns. The lens and the glass plate should be aligned accurately to ensure symmetrical ring formation. Mathematical explanation. The radius of the dark ring is given by the formula n plus fraction lambda or pi, where lambda is the wavelength or is the radius of curvature and n is the ring number. Bright rings occur when constructive interference happens and dark rings occur the destructive interference. The thickness of the air film at any point relates directly of the radius of the ring observed at the point. Applications of Newton's rings. Newton's rings are used to measure the radius of curvature of lens with high precision. They help in assessing the flatness and quality of optical surface. The phenomenon is also employed in the film research in the celebration of optical device. Experimental setup. The basic setup includes a monochromatic light source, a plano convex lens, and a flat glass plate. The arrangement is illuminated and the interference pattern is observed on a screen or through a microscope. Adjustments are made to ensure the lens and glass surface are in proper contact and alignment. Factors affecting the rings. The wavelength of the light used influence the size and clarity of the rings. Surface quality and clean lines are crucial for producing distinct patterns. Variation in the air film thickness due to pressure or surface irregularities can distort the interference pattern. Limitations and challenges. The use of monochromatic light limits the observation to specific wavelengths, which can be inconvenient. Surface imperfection can lead to blurred or irregular rings affecting measurements. Precise alignment is necessary, requiring careful handling and setup. Conclusion. Newton's rings provide valuable insights into light interference and optical surface properties. They are fundamental in optical testing and calibration procedures. Understanding this phenomenon enhances our comprehension of wave optics and interferometric techniques.